Due to the nature of the Android ecosystem, Android devices come in many different sizes and shapes, which can cause a lot of issues when designing applications that run on those devices. Now, Android screen devices are measured in dots per inch, DPI. That's what it stands for, dots per inch. So if you look at this diagram here, you notice that the less dots, the less the quality of the image is being rendered. Right? So if you look at 165 DPI, the image is very pixelated, meaning it's not a good quality. The more DPIs we have, the better the image looks. By 450 DPI, we notice now, because of the amount of dots per inch, we have a better image quality. Now, this system here can be a little bit confusing and frankly not a very good system that developers can use to actually understand or take advantage of dots per inch in Android. So Google decided to create a logical pixel density. What this is to simplify this concept of DPIs and so forth for designers. So they created a better way of designers can understand how all of this works in the real world per se. Okay, so for instance, now you have here a logical density. It would be 160 DPI. A friendly name would be MDP, so medium DPI, and the scale is going to be 1. Okay, so if we go up, it's going to be 240 logical density. That's high DPI. That's 1.5 times the first one. Okay, and we move to 320 DPI. That would be XHDPI, and 480, of course, is going to be double XHDPI, and of course that's 3 times the scale. So that is what you will be seeing. In fact, if you look back at the previous lectures where I was showing you all of the icons with all of these annotations, MDPI, HDPI, XHDPI, and so forth, this is indeed the logical pixel density that is used by Google, by Android developers. That way we can easily gauge and know what is the logical density and map it with the friendly name, and we know exactly what is expected in terms of the scale. Okay, so now that we understand density, let's talk about another topic here, which is very crucial or critical in this case, which is the density independent pixels. Okay, now the density independent pixel, also named DP or DIP, as you see there, essentially is just a representation of a single pixel unit, right? So a DIP or an Android independent pixel is equivalent to 1 physical pixel on a 160 DPI screen. So the basics, as you can see here now, it's going to be the 160 local logical density, right? That's the base density. And so we're saying here a DIP is equivalent to 1 physical pixel on a 160 DPI screen. In this case would be MDPI. Why is this important for the Android ecosystem? Well, like we said before, the Android ecosystem is very diverse. So we have different screen sizes in all these different Android devices. So we need a uniform or a more independent way of representing sizes or representing pixels. So that way, across all these devices, Android devices, we're able to express exactly what unit a certain item needs to have in all devices, across all devices. So it makes sizes of our user interfaces uniform across all of different Android devices. Hence the independent in the name, right? Because we call this Android independent pixel. These are the concepts that as you start building your applications as a designer or programmer, you need to really understand. In fact, both designers and programmers need to understand how density, the Android independent pixel works, and how DPIs, dot per inch, also works in Android. And they've done a really good job to lay all this out so that way it's easier for us to understand. So now we know 160 DPI, friendly name would be MDPI, right? And HDPI, that's 240, and we know the scaling and so forth. Perfect. I'll see you in the next video.